Welcome to lecture 5 of the course CS213 Object Oriented Programming of the Cohort University of Science and Technology. In this lecture, we will take a review of our introduction to classes and objects. We will try to understand what classes are and what are objects and how can we create classes in Java, and then how can we create objects for those classes in Java. So the agenda for this lecture is a basic introduction to the classes and objects, and then we'll have a look at the built-in classes in Java, and we'll see how we can create our classes and what are class variables and methods. The suggested reading for this course is Java How to Program Early Objects version detail in detail, and this lecture will cover chapter 3 of that book. You can also find the relevant tutorials and the official documentations relevant to these topics like the classes and the objects on the given links. And you can of course use other tutorials that are available online. So a class basically is a set of objects with a shared behavior and individual state. And we understand that the state of a class is usually shown by the variables that we call the instance variables that are associated with the class. It can be called the data of the class, it can be called the instance variables of the class. And these are basically the properties that are associated with the class, or the attributes that are associated with a certain class. And the behavior of the class then can be shown by the methods or the functions that are defined within the class. A code is stored in the class objects as a method. A shared state may be stored with the class object as a class variable. So we can have static variables for the states or the data that are shared by all the objects. An object then is objects are created from classes at runtime by instantiation. So an object then gives basically an existence to the class that we have defined earlier. An object in Java is declared using the new operator. There may be 0, 1 or many objects of a class. Instantiated objects are garbage collected if no other user-defined object can reference them. And as we have discussed in detail what can classes be, we can see in these examples, like we have two classes of different species of insects, and they can, although they belong to this insect class, then they have their own differences, different properties or attributes that differentiate the classes from each other. Then there can be properties for color, the number of legs, and other attributes that are associated with each class. Similarly, for the car class, we have different attributes for the class. They are maybe associated with each car, but the values for each object of the car class then can be different. For example, in the given example, each instance or object has its own property values that may differ from those of other objects of the same kind. So we have three cars in this example. The cars belong to the car class, but each of these cars has its own value for the objects that are associated with these cars. So the Nissan car, for example, this will have the name of the car is Nissan. Then there are other properties. Each of these have their own values for the individual objects. So these are three objects of the car class, and then these are the objects of this insect class, and these are the objects of this butterfly. This is one the ladybird maybe, and this is a beetle. So each of the individual attributes are differentiated from each other through these fields or properties or attributes that is called the state of the class. An object, on the other hand, is a building block of the object-oriented development, and it can be everything in real life can be referred to as an object, as we have discussed previously. Like if we look around us, everything that we can see or that we can touch or we can conceive in our mind can be called an object. The examples are given on the screen, but we can also look around us, and each and everything is an object that belongs to a certain class. So this object belongs to the class of clocks, maybe. This might be a flying object class belong to a flying object. This is a spaceship that belongs to the flying objects class. This is a ball, maybe belongs to the sports car class or the toys class or whatever class that we want to classify it on. And as we can see, these two are animals, but this is a different subclass of animals, and this is a different subclass of animal. So all of the things that we can see around us can be classified into certain objects or certain classes based on their common features. And this is each individual existence of these occurrence of these individual uh, objects is basically the instantiation of the class that these objects belong to. Objects have state as and a behavior. For example, the state of a dog, maybe that is an animal, can be the field or the attributes that are can be attributed to a dog. These are the things that we can, for example, identify an object from. So a dog maybe have a name, it maybe have a color. These are the attributes of the dog. We would want to see if the dog is hungry or not. And then the behavior of the dog. So the dog can bark, the dog may be trying to fetch something. If we want to like throw some object and want the dog to fetch that object, then and obviously the dog is expected to eat. Similarly, if we look at the car, the common attributes of a car that we can be associated with any car as the make and the model of the car, the speed of the car, the speed limit of that car, the number of torques that the car has, and there are many other attributes that are associated with the car, are the minimum attributes that the car is supposed to have. And then obviously there are some behavior operation that are associated with the car. For example, the behavior of a car should be if we press the accelerator, then it should speed up, and if we press the brake, maybe it should slow down or decelerate. If the car fails to perform any of these operations or functions, then there might be a fault, or we have misclassified the object into the car class. VCR, if any of you remember what a VCR is, it was the device that we used to watch movies with. So the attributes that are associated with the VCR, any electronics gadget can be like the brand of that gadget, the color that of that gadget, if it is currently the status of that gadget is if it is on or if it is off, and there can be many other attributes. And the behavior of the VCR is supposed to be it should be able to play a movie, maybe it should be able to stop when that function is called, it should be able to rewind when that operation is invoked, and it should be able to turn on. And if any of these operations fail to perform, that is, if the VCR does not go according to its expected behavior, then we can assume that there is some fault in the car, or maybe we have misclassified the object or the gadget into the VCR class. There are some built-in classes in Java. We have looked at the example of the scanner class that we need to import to take input from the user. There are many other classes in Java that are built-in. For the sake of our understanding, we will first have a look at the built-in classes that are there in Java that are already available in some of the libraries that we can import into our program, and we can use them straight away just by declaring the objects for those classes. One of this class is a point class. These classes provide us with some methods and fields that help us save time and effort in writing code and repeating it more and more. So the built-in classes basically reduce our programming effort by declaring or defining the methods that we might need frequently, and we can simply use those methods or utilize those methods or attributes by declaring the objects of those classes in our programs, and we can use them straight away instead of redefining and redeclaring those classes. For example, the point class, a point representing a location in XY coordinate space specified in integer precision. So if you are looking at the XY space, if you look at the screen, if you take it as an XY plane, then we can say that if you are pointing to a particular position on this plane, XY plane, and we can say that if this particular position can be represented by an X and a Y, like an X would be from the side of this screen and a Y would be from the top or the bottom, the distance from the top or the bottom of the screen. So that would show us the position of a particular point in the on the screen or in the XY space. And that is what we can do with the point class. If we have, for example, this is an object of the point class. It has an x coordinate and it has a y coordinate. This will show us the position of a particular point on the xy plane. Fields the fields. So the fields attributed with the class are x coordinate and a y coordinate. So every object of the point class will need to have the values for these two coordinates whenever the object for the point class is declared. And then we have the rectangle class. A rectangle, if you understand as a rectangle, specifies an area in a coordinate space that is defined by the rectangle's top left point xy, that is in the coordinate space its width and its height. So the xy values, the values for the xy variables will tell us the position of the rectangle on the xy plane. For example, if you want to draw a rectangle in this area, then we'll need to specify the position where we want to draw the rectangle, and then we'll need to provide the width of the rectangle and the height of the rectangle as well. So these are the minimum attributes that are required by the object of the rectangle class. Whenever we are declaring the object for the rectangle class, there might be other attributes like the size of the lines that we draw the rectangle with, or maybe the color of the rectangle. But these are the minimum attributes that we need to draw a rectangle on an XY plane. So the fields of the rectangle are the top left point, maybe it is the position from where we want to draw the rectangle, and then we will need to provide the width and the height as well. And it's fairly straightforward to create objects from the built-in class. We need to declare the objects, and then we can instantiate the objects. We can initialize the objects with some initial values as well. As we can see in these two examples, we have provided them with the initial values, and these are the values that may be passed on to the class or the constructor of the class and will be assigned to the object that we have declared for these classes. So the declaration is declaring a variable to refer to an object. If we, for example, just declare this, then at this moment there is no object has been created for this declaration. An object is created once we call the constructor or use the new keyword, and then we call the constructor of the class. So at this moment, this is a variable that can either a variable can either be a primitive type like the int or the double, or it can be of reference type, like for example the object of the class. This is it holds a reference to an object, and in this case, like the instantiation and initialization, now we are initializing this object with certain values. All the variables will hold their individual or explicit values for each separate object. So the point P2 here will need to provide values for x and y coordinates that will enable the point class to create an object P2. So we'll need to provide the values for all of the variables of the class that are required to be able to initialize an object for that class. The new keyword here is a Java operator that creates the object, and this is known as instantiating a class. The new operator allocates memory for the new object. So as we have talked previously, that once we create the class, it lies there as a blueprint or a model. Unless we create an object for the class, it is not initialized, it is not instantiated, it does not come into existence. Once we create an object for the class, using the new operator, some memory will be allocated to that object. For example, for the number of all the variables, and the values will be stored for those variables in the memory. The new operator returns a reference to the object it created, as we can see over here. The new operator is followed by a call to a constructor. Now, if we look at the constructor, we talked briefly about the constructor previously. If we look at the constructor, it looks the same as our class name, but then it has parentheses that is like a function call or a method call. And we understand that a constructor is basically a special type of a method, a special type of function that is there in our class. And we use the constructor to initialize our objects. So it will always be followed by a call to the constructor of the class to be able to initialize those objects. For example, point 23 with the values 2394 is a call to the points only constructor. So there can be multiple constructors inside a class. We will discuss that later. It is called constructor overloading, but the point class has only one constructor, and whenever we want to initialize an object for this point class, we'll always need to provide the values for these two variables, because that is how the constructor of the class allows us to initialize objects for this class. And the role of the constructor is to initialize the objects. The constructor in this case initializes the new object with x 23 and y is 94. If you look at this example over here, then it shows us how we can use the point class and the rectangle class, and how we can create or initialize the objects for these two classes. Now you must remember that whenever you are trying to use the built-in classes, we will need to import these classes using the import statement. If you remember, we have used import statement previously. Then you will have to use the import statement to import these classes from the libraries that these classes are defined in, and then we can simply initialize the objects for these classes. As we can see over here, or for example, object of the point class has these initial values 23 and 94, and we understand that the point has this only constructor, so that is why we'll need to initialize the object for the point class with the two values. And on the other hand, the rectangle class, as we can see here, we have two objects for the rectangle class, and the first object passes 4 values, and the second object passes 2 values to the rectangle class. And we'll see how we can define multiple constructors within class, but the constructor is used to initialize an object with certain initial values, and that is how we can do it by passing the number of arguments that are required by the constructor, and the object will be initialized to these values. The second one only takes the 2 values. It means that there are 2 constructors in the constructor class that can take different values for different objects. This constructor will have the default xy values, as you can see over here, and then the width is 50 and the height is 100. While the first rectangle has x is equal to 10 and y is equal to 20, so it has initial values for the xy coordinates. That is where it will be positioned, and then the width and the height of the rectangle are also provided. So we need to provide the width and the height of the constructor. Both of the constructors of the rectangle class needs to have the values for the width and the height, but the values for the coordinates are for the xy coordinates are optional. If we do not provide the values for the xy coordinates, then there is a constructor in the rectangle class that will initialize the values for the xy coordinates to the default values. Now we'll have a look at how we can create our own classes. The syntax for creating a class can be seen in this box right here, and we have briefly used this syntax previously. That is how we can create a class. We'll need to use the keyword class followed by the name of the class, and then we'll have the body of the class that will contain the fields that are associated with the class, and the methods associated with the class will be declared inside the body of the class. So we can write our own classes that define specific objects that we need. Each class you create becomes a new type that can be used to declare variables and create objects. So we can use the classes to declare variables of our own liking. These can be called the user defined data types as well, but we'll be using the classes to define the objects that we need. A class definition has two parts: a class declaration, that is in the first line, that is the declaration of the class, that is followed by the body of the class that is enclosed in these curly brackets. Contains keyword class followed by immediately by the class's name. The body of the class contains constructors for initializing new objects, declaration for the variables that provide the state, and the methods to implement the behavior of the class and its objects. So most of the classes that we'll be using or defining will have a minimum of 3 components. We'll usually have 3 components that are the variables for that class that will show the state of that class, and then we'll have the methods inside the class that will show the behavior of the class and the objects of the class, and we'll have the constructor to initialize the objects. And we understand that if we do not explicitly define a constructor inside a class, then Java defines a default constructor for us that initializes the values to the default values, and the default values are, there's a 0 for the integer, it was a null for a string, a 0.0 for the double, and so forth. Each class declaration that begins with the access modifier public must be stored in a file that has the same name and ends with the .java extension. So we need to be careful for, and especially when we are using an editor like a notepad, etc. When we are saving the file needs to be saved with the same name as our class name. If there needs to be one public class in our file, and then if we want to have multiple classes in a single file, then there must be one single class that is public, and the class name should be the same as the name of the file that we save that file with, and there will be a .java extension. We understand that this creates a Java file for us in our directory that we can compile later. In simple words, the file needs to be saved with the same name as our class name, our public class name. So if you want to save this file, then it will need to be saved with the myclass.java name. Class, method, and variable names are identifier. All use camel case names. and there are some specific rules that we need to follow. For example, for naming our variables and methods and classes that are usually similar to, are mostly similar to C++. And there are some naming conventions that we follow. So in Java we follow the camel case naming convention, that is the first letter of the class is usually in capital letter, and if we are joining two words, then the first letter of the new word needs to be in capital letters as well. For variables and methods, we start with the small letter, but if we are joining multiple letters, then the first letter of the new letter, the first letter of the new word needs to be in capital letters. Instance variables of the class are the variables that show the state of that class. Instance variables are dynamically allocated, which means that these are different for each different objects of the same class. For example, if you can see in this class diagram, we have a class ball, then there are these variables associated with the ball, and these are the methods that are associated with the ball. So this box shows us the class diagram of a class ball. In the first compartment we have the name of the class, in the second compartment we have the variable names along with the data types of the class, and these are the, and then we have the methods with their return type and the number of arguments are the parameters that these methods are going to take. So we can use the UML class diagram to design our classes before we implement them in our program, that tell us the name of the class, the name of the names of the variables names, and the data type of the variables, and the names, the return types, and the number of parameters of the methods that their class is going to take. Instance variables are dynamically allocated, so they may have different values in each instance of an object. So we have 3 objects for the same ball class, and each of the object has different values. For example, the B1 object has X position 10, Y position 20, color is red. Similarly, B2 has X position 10, Y position 10, and the color is blue. And B3 of the ball class object B3 has X position 5, Y position 5, and the color is green. So each object will have its own values for the instance variables of the class. A class declares the type of the data, but it does not reserve any memory space for it. We understand that the memory is only allocated for the class when we create an object for the class. When an object is instantiated, the runtime system allocates some memory to this instance so that it can remember the values it stores in instance variables carried with it throughout its lifetime. The values are associated with each object, and memory is allocated for those values, but it is only allocated memory once we declare the object for that class. Instance variables exist before methods are called on an object. A class normally contains one or more methods that manipulate the instance variables that belong to particular objects of the class. If you remember the BMI calculator that we use, and we will have a look at it again in the example, that we have certain variables in the class, then we can use some methods that manipulate or use those variables to perform some calculation on those values. So I will have methods inside our classes to use those variables of the classes for our purpose, and instance variables are declared inside a class declaration but outside the bodies of the classes method declarations. We will see that we can have local variables in our classes as well, but the local variables are declared inside the methods of the classes, but the instance variables are declared outside of the methods of the classes, and these obviously need to be inside the classes, but these will have to be outside of the method declaration. If we declare variables inside the methods, then those variables become the local variables of those methods. We'll have a look at this in our example implementation as well. For example, if we look at this BMI calculator example, that was one of your lab tasks. We have three variables. We have declared three variables. One is for taking the input from the for the weight, and one is for storing the height. We have three variables. One is for storing the value of for the weight, one is for storing the value of the height, and then there is BMI that will store the value that is the output that is calculated by manipulating these two variables. Now it can be manipulated with a certain formula. That formula calculates the BMI when the weight and the height are given. Now we will be using methods to manipulate these variables and to take some output from the user, and then we'll be using an object of this class to display the output of this calculation. So we can use the variables that are given to us, and we can directly put values into this, but this is not something you can follow in vectors because this will store the same values for all the objects of this class. Alternatively, what we can do is we can use a constructor to initialize these variables. Now if we do not have a constructor, we understand that we have a default constructor in the class that initializes the variables, the instance variables, to the default values. If you remember, the default values are assigned by the default constructor by default to these variables. And if we try to calculate this, now how can we calculate this? We can use an object for this class. So if this is how we can declare an object. Now since we do not have a constructor in our class, we can call the default constructor. Default constructor is the same, works the same as an empty constructor that does not perform any initialization. But if we do not have a constructor in the class, then a default constructor will be declared for that class. But we need to remember that once we declare a constructor in the class, then the default constructor does not exist. So if I call this method with the default values, let's see what output does it produce. So it has produced an N. If there is nothing that it can calculate using the default values, if we want to maybe display what are the values stored inside these variables, we can use another method. We'll talk about the public and other access modifiers in maybe in the next lecture. Just to try to understand, like if we try to display the values that are stored inside these variables, then maybe you'll be able to let's say see at what are the values that have been initially assigned to these variables by default. So if I now call this display method by using the object of this class, the object is like this is the name of the class, and there is the name of the variable or the object that we want to create. The new keyword is followed by the equal symbol, and then the call to the constructor. Now you can see that the constructor is the same as our class name of the constructor is the same as our class name, and the constructor does not take any return type. We will see, look at the constructor in our upcoming lecture. So if I call the display method now using the object, and we'll be able to see what are the values inside our variables. These will be obviously the default value. As you can see, it prints us like your weight is 0.0 and your height is 0.0, and again it cannot calculate the BMI given these values. If we maybe try to assign some initial values to these variables. Now this is not how we usually assigning values to our variables in object-oriented programming. We will be using the constructor for that purpose, but at the moment we just want to see how our program behaves when it is given some initial values. If we run the code again, we might be able to see these initial values now, and your BMI is able to calculate the initial the BMI now given these values. So your weight is 90 kgs and your height is 1.7 meters, and it is calculating the BMI given these two values. This is how we can maybe use the variables inside a class and use the methods to use those variables to calculate some kind of an output or some kind of perform some kind of a calculation given those variables. In our upcoming lecture, we will look at how we can use a constructor to initialize our variables, and how we can use other methods to change the initial values that have been assigned to our instance variables. Now these are the instance variables that are supposed to be different for each object. The values for these variables are supposed to be different for each object that is created for this class. So if we create another object, maybe in this case we are not able to change these values since we have used direct assignment of the variables. We have assigned some values to directly these variables, and no matter how many objects we create for this, we won't be able to change those values through the object that have been initially assigned. You can only change these values using maybe direct assignment over here, but again our output would be the same for no matter how many objects we create for this. So we will see how we can get around this issue over here, but this program just shows us how we can use the instance variables and the methods that work on those variables, and then we can create an object that we can use to call the methods inside our class. And we'll also look at this public keyword that we are using over here, the access modifiers, and if I try to let me access the variables from over here, now it allows me to access these variables over here as well, which is something that we would try to avoid. In our object-oriented programming, and we'll be trying to provide a controlled access to our variables, our instance variables. And now we can see that we can access those variables, and we can change the values for those variables right from outside of that class. That is a separate class, that is the class with the main method, and we are able to access the values from our separate class directly. We are able to access the variables, and we are able to change the values for those variables, because currently the access for these variables is package level. That means if they are within the same package, then they are able to access each other. Now we'll see how we can restrict the access for these variables from outside of the class, and we will be looking at how we can provide a controlled indirect access to these variables